Hello students, this is SAHA tutorial hub. Today we will discuss about the application of differential calculus, and the topic is Maxima and Minima. Very important topic, and students should know for higher mathematics very clearly. Where Maxima creates, where Minima creates. Uh, this is the focus of our topic, Maxima and Minima. So we need to know first that what is the behavior of a function. Let y equal to fx is a function where x is independent variable and y is dependent variable on x. So take a Cartesian plan. Cartesian plan. This is x and this is y. Now a function can have many behavior on Cartesian plan. Let's take y equal to fx is passing through in this way. So I am taking an interval here. This is a 0, a0, and an interval b0. Now here we have to find the point where the curve takes minimum value. Means this is y equal to fx. This curve is y equal to fx. Such a equation of x that is satisfied by this curve on the Cartesian plan. So this is the curve which is satisfied by the y equal to fx curve, fx equation. Now look this. This is the value of fa. So it will be in Cartesian plan a fa and this will be, this point will be b b fb. fb is the height of the line. This is b fb. This full line is fb and this full line is fb. So the curve where takes maximum value of fx. Here this point you can note that look this point, and this point, these 2 points. Here fx takes minimum value. Here fx is minimum value. fx takes minimum value. X takes minimum value. In this interval a to b, and here fx takes maximum. fx takes maxima. Maxima. So, for which point? Which point? This is the point of x for which f is taking maximum value. So we have to take this is take uh, d point d0 for which x equal to d for which the value taking maximum value. Here f is taking maximum value. And this is the point. Let c equal to 0, c 0, x equal to c, where f is taking minimum value. So what the condition we can what we can make a condition for which we can find a maximum or minimum in a interval. There needs a condition of course. Look this behavior. We know from the definition of differential calculus that we know we from the definition of differential calculus that dy by dx equal to limit h tends to 0 if x plus h minus fx. This is very important and you have to understand this for maxima and minima and by each. Now h tends to 0 means h tends to 0 plus and 0 minus from both sides, from minus side and from plus side. So where the minimum value is, where the maximum value is of fx, there a behavior can be marked of this differential calculus that here the neighborhood of x equal to c, we find that because it is the minimum, the curve is very minimum, or in better condition here you can look x equal to d point, the same condition you will get find for minimum or maximum. So I am understanding here is more clear curve. So at the point of x equal to d, in the neighborhood of x equal to d, you can see that the f x plus h, the immediate neighborhood of h point, such kind of point you will get such fx plus h or fx minus h there, because it is a maximum point. So fx plus h, and if the h point tends to 0, since h tends to 0, you will get fx plus h in the limiting value. Of course, in the limiting value, you will get very nearly equal to fx, very nearly equal to fx. And then if you take the limiting value, it must be equal. In the limiting value, if you take limit of this, then you will get fx plus h minus fx is equal to 0. For the right hand of differentiation, and left hand of differentiation, you will also get that in the neighborhood fx minus h, if x minus h also very nearly equal to of fx, but in the limiting value these are equal. So one condition can find that for both the minimum value of fx or maximum value of fx, you must get that the upper of the two functions subtraction must be equal to 0. So what is the condition we get in the maximum point or minimum point? The differential must be 0. It means that at maxima maxima or minima minima, the first differentiation of any function means dy by dx is necessarily equal to 0. Dy by dx is necessarily equal to 0. This is the first one. So for maxima minima, if any function have, then we get first derivative must equal to 0 at some point. If any of them exist, maxima or minima or both, then dy by dx at some point in any interval we get must first derivative of the function equal to 0. So this is the first condition. And second is, if the second derivative of is taken, then what will be d square y by dx square 1 point that limit h tends to 0 and prime for first differentiation to first derivative prime a prime x plus h is the first derivative of the function f x plus h minus f prime x. This is also the first derivative of the function f(x) by h. So now we know that at the maxima or minima, if this x must be 0. So if it is 0, then the neighborhood functions first derivative what will be? If we will get the if we can create again the function, take this is the maximum. Here a point we are getting where we getting maximum. So here first derivative of x is equal to 0, but in the neighborhood of fx plus h, here is the neighborhood. Here the neighborhood function. This is fx plus h plus h. Here we will get some value, but less than fx, because fx is the maximum. Here fx is greater than fx is greater than fx plus e. So when we will go to first derivative of the function, then it will be 0, but the first derivative of this must be And also you can mark that if you take negatively x tending h minus, then also you get fx greater than, the fx is maximum at that point, fx is greater than x minus h. So there is a point to understand that fx is the maximum. So you get, you can look this, that at the maximum point both fx minus h or fx plus h is less than fx. So so here in the limiting point, because this is its first derivative, also it will be smaller than this, means it must be negative, because if this is 0 at maximum point, so and it will be smaller, so it must be negative. So if in the in the second derivative of this function we will get negative value at any point, then negative negative value of any function, second derivative of any function, if we getting negative, then we say that there must be a maximum. In case of minima, you can look this. In case of minima, the there is the function. Here is some point where is the minimum value. So here we have to mark that in the neighborhood of x, there will get, we get that fx is minimum from this is fx plus h, this is fx plus h, this is fx minus h, and this is fx. This is fx. So here one thing to note that fx is less than fx is less than from both of the values. Fx is less than from both of the values, fx plus h, and also less than from fx minus h, because this is the minimum value, and in the x, if we take in the neighborhood, if we go in negative direction or in positive direction, we get fx plus h, and fx minus h is more bigger than fx, because the curve is minimum at this point. So fx must be smaller than both of these values. X minus h. So what will be the condition of the second derivative here? D square y by d square y by dx square. Do this. Here the limit is tends to 0. Prime first of x plus h minus prime x prime of x by h. Here you know that the prime value derivative must be equal to 0, as we know the condition that minimum or maximum this must be equal to 0. But here is both are greater than fx. So is first derivative of these functions also greater than the first derivative of fx. So this is 0 and these are the this is greater than of this. So you get mass its value positive. So if we will get positive of value of second derivative, then we must say there exists a minimum part. So this is the difference of maximum and minimum. Second derivative gives so positive value, then positive value. Then we say that there is a minimum of there is a minimum value of fx. And if we get second derivative of the function for negative, then we will say at that point there is the mm, maximum value of the function fx. So now take an example. Here we have example. Fx is x minus 3 and x minus 1. Solving this will get, if we solve it, we will get x square minus 3x minus 4x plus 3. Now we have to find out the maximum and minimum. We have to find out the maximum and minimum. Find out maximum or minimum or both. Maximum or minimum. If there exist or both exist or any one exist, then find out. Then how can it be done? I have given the condition to find out a maximum or minimum. First derivative of fx must equal to 0. So take first derivative of fx. What it will be? First derivative of fx, it will be 2x minus 4. So it must be equal to 0. If there is maximum or minimum, it must be equal to 0. So it is 0. Then what the value of x will get? Solving it, we will get x is equal to, very easily can be calculated, x equal to 2. So at this point there is also one thing, cannot exist. We cannot get 2 points, just 1 point we have got. So there is either maxima or minima. So we have to find second derivative to judge there is maxima or minima. So we'll take the second derivative of it. Second derivative we will take, then we will get x, we will get just 2, which is positive. at the point 2 we have to find, but this function is not dependent on x. So if we put here if first derivative we are finding at point 2, what is the value of the second derivative at the point 2, so we will get 2 because it is does not depend on the values of x. So it is positive, means there is a minimum because it is positive. So we are getting a minimum at x equal to 2 positive. So we are getting, we must get minimum at x equal to, so we get minima x equal to 2. So the minimum, we can also deduce the minimum. We have already proved that at x equal to 2 there is a minimum value. So what will be the minimum value at the point of x equal to 2? So we can just do this by putting the function we have taken f is equal to, we have taken x square minus 4x plus 3. So we'll put replace x equal to 2 and get the minimum value. So the minimum value of x is minimum value will be f2, this will be 2 whole square minus 4 multiplied 2 plus 3. So solving it, we will get 2 to the 4, 4 and 3, 7 minus 8 is equal to minus 1. So minimum value will be minus 1. If we draw the curve, it will be, this is 10. This is 1, this is 2, this is 3, this is 4, this is 5, this is 1, 2, 3, 4, 5, this is minus 1, minus 2, minus 3. So at x equal to 2 we get, there is the minimum value. So there is a point and here must be minimum. So the function will go in such a way. No other point, in the no other point other than x equal to 2 we will get maximum, minimum. So x equal to, there is a minimum. So this is the minimum value. This is 2, 2 minus 1. I think it is clear now through graph also. Find out minimum or maximum. So go to practice in your textbook every kind of mathematics of maximum minimum. If you have any question related to the maximum minimum, ask me in comment box. Send me the comment on YouTube and subscribe this channel. Subscribe this channel. It will be more easier to send you any topic if you subscribe this channel. So it will be easy for us to send you any new videos. So That's why subscribe and share with your friends. It will be more good behavior, because if you share with your friends, discuss with them, then math will look more easier. So must share with your friends. And like also, and if questions you have, then ask me in comment box. So, thank you. Have a good day.